Now that we know how to handle absolute value inequalities where the absolute value is on the greater side, let's work through a couple examples. So first example, let's solve for m. In the inequality, absolute value of m minus 7 minus 3 is greater than 13. So the first thing we should do is isolate the absolute value, right? So let's add 3 to both sides. We get, on the left, we get absolute value of m minus 7 is greater than, on the right, 3 plus 13 is 16. So absolute value of m minus 7 is greater than 16. And now we have an absolute value inequality. The absolute value is on the greater side of the inequality. So that means that the stuff inside the absolute value, m minus 7, is outside the negative and positive versions of 16. So that means m minus 7 is less than negative 16, or m minus 7 is greater than positive 16. Or maybe it's better to write this in order. So 16 less than m minus 7. Right? Writing it in this order makes it sort of visually look like m minus 7 is on the outside. So that's why I wrote it in that order. Okay, so now we have two inequalities. We just need to finish solving both of these inequalities. So for the first one, m minus 7 less than negative 16, let's add 7 to both sides. We get m is less than 9, negative 9. Or, and now we need to finish solving the second inequality, add 7 to both sides. We get 23 is less than m. All right, so here's our solution. Either m is less than minus 9 or greater than 23. If we wanted to graph this, right, we need 23 on our graph. We need negative 9 on our graph. Notice I'm using open circles for 23 and negative 9 because this inequality is not or equal to. Okay, and then let's see, we need to mark everything to the left of negative 9, so to the left of negative 9, and to the right of 23, like this. So there's our graph. And then for interval notation, it would be the interval from minus infinity to minus 9, not including minus infinity or minus 9, union, so that cup symbol, the interval from 23 up to positive infinity, not including 23 or infinity. Okay, so there's our solution written all three ways, as a graph, using inequalities, and using interval notation. All right, let's look at one more example. Let's solve this inequality for n. 9 less than or equal to 3 times the absolute value of 9 minus 3x, and then outside the absolute value, minus 9. All right, first thing we need to do is isolate the absolute value, so add 9 to both sides. We get 18 less than or equal to 3 times the absolute value of 9 minus 3x. All right, now divide both sides by 3 to isolate the absolute value. On the left-hand side, 18 over 3 is 6, less than or equal to. On the right-hand side, the 3's cancel down to 1, and we get the absolute value of 9 minus 3x. Oops, I'm writing x, but the variable is n. So absolute value of 9 minus 3n. All right, now we need to deal with the absolute value, and the absolute value is on the greater side of this inequality. So the stuff inside the absolute value goes outside the positive and negative versions of 6. So we get 9 minus 3n is less than or equal to negative 6, or 6 is less than or equal to 9 minus 3n. And now we need to solve each of these inequalities. Something you might have noticed is that we keep doing the same steps to solve these two inequalities. So we can kind of solve them both in parallel at the same time rather than doing one completely and then doing the other. So first thing we need to do, first thing we need to do is subtract 9. So let's subtract 9 from both sides in both inequalities. So in the first inequality, we get minus 3n less than or equal to negative 15. In the second inequality, we get minus 3 less than or equal to negative 3n. Now we need to divide everything by minus 3. Now we're dividing by a negative, so remember we are going to have to turn our inequalities around. Okay, so in our first inequality, we get n greater than or equal to minus 15 over minus 3 is 5, positive 5. So n greater than or equal to positive 5. And in our second inequality, we get 1 greater than or equal to n. All right. Now these inequalities sort of seem out of order again because the first one is describing the big side and the second one is describing the small side. Again, that happened because we divided by a negative number, which turned everything around. So let's put things in the usual order. So either n is less than or equal to 1, or 5 is less than or equal to n. Right? So writing it out this way puts the small side on the left and the big side on the right, which is a little nicer. Graphing this, so we need to mark 1 with a solid dot because 1 is included, and everything to the left of 1. And 5 is included, and everything to the right of 5. So everything to the left of 1, 1 included, and everything to the right of 5, 5 included. And then writing this using interval notation, we have the interval from minus infinity up to 1, including 1, union the interval from 5 up to positive infinity. And that's our solution.